Welcome back, Generals, to another Let's Fix General 0 Hour to make the best game ever. Good, let's see what's new here in our notifications. One new. Indian Compat. Yeah. Let's see. Okay. Okay. So I guess it's not meant to be added to. Okay. Okay. So big endian to host. Big endian to host. Big endian to host. Big endian to host. What is N2HL? What is that? N2HL. Converts the unsigned integer host long from host byte order to network byte order. Okay. Network byte order. Network byte order. Okay. Okay. So N2HL Windows. Byte order returns a 32-bit number in host byte order. Convert IP4 address in network byte order to the IP versus 4 address in host byte order. This function does not do any checking to determine if the net long parameter is a valid IPv4 address. Which is the host byte order. Hold on. Host byte order. Host byte order, which is little endian. Converts a ulong from. Okay, so N stands for network and H for host. Network to host. Okay. So can we let me check the H2N. Okay, so the network is big endian. Big endian. Network is big endian. Okay. Network is big endian. Big endian. So this is Open Archive reading. Open Archive, big endian. Okay, then I think this is correct. Yeah. Big endian to host. Okay. What about the big endian file system? Oops, wrong. Big file system. Win32 file system. Win32 file system. Open archive file. Win32. Open archive file. Okay. That also uses N2HL. What about the N2HL calls in that? Shouldn't we adjust it there as well? Okay, so this guy, I guess we can merge there. Squash and merge. Let me see. Relates to 555. Let me go in here. 819. Move libraries. It's a move misc library. Move game. Let's do profile debug. Maybe we can also figure out what else we need to move. Hold on. So we have let me go here. No, here. So we have include lib base type trig RTS debug profile. Oh, what is this? Oh. Maybe we should move that as well. Proxy header for profile module. Are these included? Let me see. RTS / debug.h. No. RTS profile.h. That is included. Pre-RTS. Okay, looks like we should also move these guys then. Let me go back to this guy. So we're looking at include RTS. Include RTS. So let's say we move these guys here. And then we do let's see if that would compile or not. Huh, that has just compiled. Include RTS profile. How does this find this? It shouldn't find it. Okay, now I'm a bit confused here about this thing. The profile. How does it find that? Is it even compiled? Win main. Certainly that is compiled. How does it find this file now? We have moved it, but I shouldn't see this file. How does that work? Huh. I don't know. Core. 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 Ah, it finds it because of this here. Uh-huh. Uh-huh. Okay. 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 Also move the libraries includes headers. Let me rebuild it though, just to make sure. Yeah, but we can push it already, I think. Okay, so we got that. Is there anything else that we should move? Let me see. Probably not. Okay, main, what is main? Game engine device. Game engine. I think that seemed to be possible. File xfer string bezier video input random. Maybe we take a notes of these here. Let's call it game engine file. Game engine xfer string bezier video input random. Okay. Okay. This one we have moved in parts. Closed. This one 814. Relates to 555 814. You have a pretty good overview already. That's good. Then I think what we can do next is you can move maybe game engine file or one of these. Start moving some of the things, right? Move many unified ww3d2 library files to core. Yeah, good. Let's see. Fix freeing reference counted pointer based memory leaks. What? What about end calls and that? Shouldn't we adjust it there as well? We can't yet without breaking VC6 compat, but it includes the WinSox header directly to gain access to N to HL. The ping was indirectly gaining access. WinSox was not actually cross-compatible and lost access. Right at the 0-hour ASCII string class. Lost access. Well, can't we just say? Can't we just do? Can we just do? Define B2 for VS6. Or can't we just do define BE32 X no. Good. Let's get back here to our code, which we also checked in the previous video. Good. So we wanted to write the function trim unreachable instructions, right? Okay. How far did we get? I will be right back. Good. So distance, trim unreachable instructions. Good. So what do we want to do? We want to target address, distance. I think we can also make this const. So if we take a jump here, jump not taken, I think that doesn't need to take it. That just goes on. Yeah. Okay. So if we take a jump, then we need to do I plus equal distance, right? Distance dot value. Right. And we do a static cast. Do we have a downcast? Downcast, no? Downcast index T. And here as well. Okay, so but we also need to take is unconditional jump, is conditional jump. So we also need to take the snapshot right here. Do we need to take a snapshot here? No, because it is always jumping. Yeah, it's always jumping. Okay, here we need to take now a checkpoint. Checkpoint dot push I. There. Okay, I think that makes sense. Yeah. And here we don't need a checkpoint because it just does it. Yeah. Yeah. If it's unconditional jump. Hold on. Unconditional jump take. Set. I think here, when we have the else, we should say, what do we say? We say, it's unconditional jump. It's unconditional jump. I think here we need to do continue. Continue. We do the same here. So if this stuff is complicated. So it's an unconditional jump. We reach it and we check, have we not taken the jump yet? If we have not taken the jump yet, we try to take it. If we can, then we set the index to that and then we jump. Do we need to take a checkpoint? No, I don't think so. There's no checkpoint needed. But what do we do if we have already taken this conditional jump? Then we know we already reached it. That means we can do that means we need to do this check here, right? Maybe. Let's think about it. So if we hit a return, we check if this, we max this guy, yeah. We check if we have any checkpoints left. If we don't, we are done. If we do, we go back to a checkpoint. And we do the same here on the unconditional jump. If we have a checkpoint, then we go back to the checkpoint. Let me just to be explicit, let's type in continue to put the intent. It's not necessary, but just makes it a bit easier to read, I think. Here we break and here we continue. And then, it seems to make sense, but I need to think more about this. Good. In the conditional jump. So the first, if the jump was not yet taken, we take the jump. Yeah. Okay. Blah blah blah. Okay. And then we go here. If not condition jump not taken. I think at the end of it we need to do the same thing here again. Say we reached this point before. Well, hold on. I don't think. Let me comment this out for now. So let me remove this here as well. So if the jump, if we have not taken the jump, then we also go forwards. Then we just continue here. And otherwise, what do we do here? Can it hit here? Oh, oof. Good question. If we hit this thing and we have went both routes, then it's similar to like when we reach here. So this jump is basically exhausted, right? We have taken both routes before. And is that possible? Probably is, yeah. And then what? This I'm pretty sure that this will make load times much longer. Because it's quite some intricate logic. It needs to go a lot of loops there. I think this will be extra expensive. Oh boy. Oh boy. I could add a couple seconds to the load, I estimate. Yeah. Because every function needs to do it. And there are 20,000 functions or so. Right? At least those that have symbols. Oh boy. Oh boy. Oh, Jesus Christ. So what do we do if we reach that point? We've already... Well, it should do the same thing here, right? It should check if we have checkpoints. Should go to the checkpoint. But it can't be that we... Is it possible? Hold on. Is this possible, or should there be an assert here? I'm a bit afraid that this eventually... This prematurely breaks the loop. Right. not sure. How about we just copy it here and we just make a trial run and see. It's easier to see what we're doing. Yeah. Just make a trial run, see what happens. Yeah. Okay, let me put just a breakpoint here. Yeah. Now see if it compiles. It looks like we're going in the right direction, but there's probably a lot of errors in here. It's very likely, yeah. Classic logic errors. Okay, what do? We select these guys. We do this, compare, let's go. Let's go. Okay. I would have to add a definer around all the incompatible stuff in the Onion comment header and remove the compile guard, as I just said at the beginning of the header. Well, I mean, only the static assert should be incompatible, right? Yeah, I think only the static assert is incompatible. Everything else should work. I would expect that only the static assert would need substitution. So that only the static assert would be incompatible. Yeah. Okay, so what do we have here? Last instruction index. Okay. Oh, I already see. No, that's not. Oh, last instruction index. Could have just called it instruction count. Okay, so let's see. Let's put breakpoint in here, and in here. Yeah, okay. Let's see. So instruction is 17, and it should go in here. Yeah. Now we have taken this jump, and the target address will be some number. Distance 60, 96. 96 has value, checkpoint, push. Okay, and then it will increment and it will continue. Okay, then what? Then it goes down here and down there. Okay, let's see. Now we are at index 116. And we have another conditional jump, and the jump is not taken, so it will take another jump, minus 102. Yeah, minus 102. the way, I wonder... I think there's a grand mistake in this logic. There's a grand mistake in here. Oh, is there not? Hold on. What if we... No, there's not. If we reach this here, it's guaranteed. It's supposed to be the last return. There should be no other conditional left to visit. Yeah. Oof. It's really questionable that this all works correctly. Continue. Okay. Okay. Okay, so is conditional jump. Okay, so we have already taken this jump. It seems to be like a loop or something. And now I have not taken the jump. Yeah. Jump not taken, continue. Okay. And then okay, conditional jump. Now it will do one of these acrobatics again, yeah. By the way, here we should probably have an else assert, right? Maybe. Not sure. Instruction. Okay, here we reach an end point and we pop. Okay, so we go back to a checkpoint, checkpoint 21. Okay, and then we go here. Okay. Okay, let's just jump around here. Conditional jumps. It makes sense that we have conditional jumps. Let's put a breakpoint down here. Let's put a breakpoint here. And here and here. Oh, we hit a return. Look at that. Okay. It's not the end. Okay, so it goes back to our checkpoint. And now we're done. Okay. Was this all correct? I don't know. Last instruction index reached. Five. 13. Break. Okay, so far it looks pretty decent. I do see there's probably an error here. Last instruction index reached. should probably be I+1 or resize. Yeah, let me do some renamings here. So this is instruction count. Instruction count. Then we do here, last instruction is this, resize, and we do this +1. Yeah. I would like to add a few more sanity checks here. I would like to add, so we know how many conditional jumps are in there. So we expect to, let me see, we expect it, unconditional jump. We expect to visit we expect to visit all the, well, I mean, there could be something that violates it, right? Like, let's say you have a jump and then behind comes a return for some reason. I don't know if such code can be generated, hopefully not. But then we wouldn't be able to reach the return if the previous jump would always jump somewhere away, right? Bit array. What is this here? Didn't crash. Let me think. It's okay, I think we can merge this guy, and I think this one also should be good. Yeah. Good, then let's merge this guy. Delete. Squash and merge. Move debug and profile from 0 hour to core. Okay. Okay, what's the deal? We need to... No. How can we verify this logic that it works correctly? We want to visit all branches, right? So we want to visit all branches. Maybe we say else if I have idea instruction dot is return plus plus we say un32t return count 0. How about we do this? We make this an integer. Integer. And then we do un32t and then here we do jump count. Here we do minus minus unconditional jump count. And then here we do hold on, conditional jump count minus minus, and here we do minus minus return count. And so the expectation that I currently have is that here at the end, all these counts should be 0, right? Conditional jump count is now expected to be 0, but I'm pretty sure there's something that violates it, either by randomness or by logic mistake. Yeah. I would be pretty amazed if this now, if all these are 0. If it is true, that would mean it would be all correct. But I have my doubts. I have my doubts. Let's see. Let's return. Minutes. We need a lot of patience here. A lot of patience. Okay, good. So let's see. Oh, 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 okay, well, that already violated. Okay, well, conditional jump count, instructions 186. Okay, so that didn't work. Yeah, that didn't work. I think it doesn't work because, like, let's say there is a, well, why would it not work? I'm not sure. Because it can exit here, I guess, right? Yeah. I think it's because it exits here. Let me put a breakpoint here. I think it must not exit through there. Let me put these into conditions that we can skip if not that, int a equals 0. Okay. Okay. Let's put breakpoints here. Probably bug somewhere. Okay. Yeah, there we go. This is a problem that it breaks out here. I see. Okay. Yeah, it shouldn't really break out there because yeah. It needs, well, what should it do then? What should it do? Oh. Conditional jump not take. It should should probably just continue, right? Continue. Yeah. Unconditional. I suspect that it would need to continue here at this point. Right. I think I will continue thinking about this next session. Yeah. I think we can take a break here. Yeah. So basically it has visited this conditional jump already twice, right? And now it visits it a third time. And then that means it just... I guess it then just needs to continue here, right? Okay, let me change that to... Let me just put a continue in here for now. Yeah. Let me see. Oh, debug session speed is crazy here. 1 minute 30. Well, okay, so it has reached this and now it will continue. So we go to the next instruction. Then I reaches another continue, and another, and another, and another. Okay, let's stop. And it hits a return. Okay, great. So what are our counts now? -2 returns. Uh-oh. Oh boy. Conditional jump count 6. So we didn't visit 6 conditional jumps. Is that right? Oof. Return count -2. Ah. Hmm. 6, 0. Yeah, I think we need to think about it next session. Something is fundamentally wrong with our logic. It is this. It is wrong. Right now I'm not sure what the error might be. The error. It's probably, I don't know. I would like to know, but I admit I have currently no idea. I would have thought it would visit all branches. I could be mistaken. Maybe it doesn't because we do this here. I'm not sure. Hold on. I see a problem. If we would go from one conditional jump to the next one, then we lose our previous checkpoint. Yeah. Yeah. So that is certainly wrong. We lose a checkpoint. So no, we don't lose checkpoint because we have a stack. Never mind. Never mind. No, I need to think about it with a fresh mind right now. I have no clue. No, I also don't know how to debug this other than thinking hard about it. We don't have any visual aid for this, right? I guess what would help is if we looked at the assembler side by side and followed it, the control flow, and look at the assembler as well. There. Yeah. We have the instructions here. Yeah, let me worry about this next session. I will take a break here. Then I wish you a great day or night. Until next time, goodbye.